So let's start, Peter, with some terminology. An object that is launched through the air, we call it a projectile. Although, as always, Noah, if I'm going to be nitpicky and fussy, we should point out we're going to ignore air resistance. And the other thing we're going to actually be assuming is that the Earth isn't round, it's flat. The Earth is round! But if we were going to do this properly, especially if we were launching projectiles long distances, the Earth would start to curve away from the projectile, and then for us to find its height would be much, much more difficult because the Earth is curving away from it. So we're going to assume, at least over a distance of like 2 or 3 kilometers, the Earth is basically flat. There's a tiny bit of curve, but not much. But we'll definitely ignore air resistance. We can think of a projectile as experiencing 2 types of motion simultaneously. Remember the demonstration that I did before I started recording with Kenta and I. We said you can think about it as having horizontal motion and vertical motion. I am not writing those 2 words down again. I'm going to abbreviate. You might think that H and V would be good letters to use for abbreviations for horizontal and vertical. They're terrible because V is already taken by velocity, which will show up in the equations that we'll be using here, and H is height, which probably is going to show up in what we're doing here. So I'm going to go to some math notation. What variable do we use to show left and right on a graph? I'm going to use X as my abbreviation for vertical. Which variable do you think I'm going to use as my abbreviation X as my abbreviation for horizontal? Which variable do you think I'm going to use for my abbreviation for vertical? Because I asked you to. Which variable am I going to use for my abbreviation for vertical? Because I asked you to. Which variable am I going to use for my abbreviation for vertical? Now, most of you got that joke. Someone can explain it to Peter later on. Because I asked you. Really what that means is when Kenta and I were playing catch, the vertical component of the velocity got smaller. For a split second, the vertical component was 0, and then it got bigger but negative. Oh, and the speed that it left going up was the same as the speed if we had caught it at the same height that it arrived at, but going down. Horizontally, Kenta, do you notice each little chunk is the same, and that's because horizontally, no acceleration. What we say is this: the horizontal velocity, I'm going to abbreviate that as Vx, is constant. Because what was the vertical acceleration exactly as a number? No, that's... Oh, sorry, did I say horizontal? Yeah, horizontal. Horizontal is what? Yeah. That bugs some kids sometimes, so let's do a little prove it. Okay. Physics 12. This is a really expensive piece of equipment, so I haven't bothered purchasing it. It's about $600. I have a lousier version of this that I just can never get to work. So what we have here is a golf ball gun. It's a cannon. It's a spring-loaded cannon. It's going to fire the golf ball straight up. What we're going to do is we're going to give the cart a push sideways. When it gets to this trigger, it's going to launch the ball. And ideally, we should see the ball stay right above the cart the whole time. If it does that, since they're both not accelerating, we can say the ball has a horizontal acceleration of 0. Let's arm it. Let's load it. Here we go. What do you think? Did it come back? Did it stay underneath the whole time? Let's watch it again in slow motion. There's the launch. Mr. Dueck, but Callie, I think it was a tiny bit forward. It is true that it's not perfect, and the reason is it's really tough to get the golf ball to go up exactly 90 degrees to the ground. I'll bet you it was like 90.2 or something like that. But in our magic physics world where we could do the experiment perfectly, you would have seen it come dead center. Is that all right? You can try this yourself if you just walk at a constant speed and throw a ball in the air. Sorry for those of you at YouTube, but if I walk at a constant speed, watch. The ball came straight back down to my hand. Did not end up behind my hand, didn't end up in front of my hand, and that's because I was walking at a constant speed, so what's my horizontal acceleration? 0. Well, if the ball stayed relative to me in one place, what's its horizontal acceleration exactly as a number, Cameron? 0. Vertical velocity is not constant. Slows down, and then speeds up. And it's changing because the vertical acceleration, which I'll abbreviate as AY, is, exactly what? Negative 9.8. So what does that mean? It means to solve projectile problems, we're going to divide the question into what we call horizontal and vertical components. In fact, in the same way that, this is a job for a free body diagram, was a good tool for forces, here is the tool for projectiles. I call it a T-table. Can anybody guess why I call it a T-table? Looks like the letter T. And on the left-hand side, I label that as horizontal. You can write it out, but I'm going to abbreviate. And on the right-hand side, I label that as vertical. And then in Physics 12, I'll teach you to write down, we'll nickname them the two physics no-brainers. They're not. You have to know some physics, but once you know some physics, you can say, what's AX exactly as a number? What's the horizontal acceleration exactly as a number? And what's the vertical acceleration exactly as a number? You can write those down as long as you're on the Earth without even thinking about it. They're sort of no-brainers. And then the rest we fill in based on the question. Okay. So, I know this. AX equals what? 0. AY equals... What else can I say? Well, above this, can you write D equals VIT plus a half AT squared? Remember our old friend? That was our displacement equation. I can customize this one to both horizontal and vertical. Horizontal, I'm going to write dx to show I'm talking horizontally, and it would be vxt. Oh, why didn't I bother writing the plus a half at squared? It's 0. That's the equation if you're finding a horizontal displacement for a projectile. Vertically, it's going to be dy. That's going to be vy initial t plus 1/2 ay t squared. How come I put a y or an x on the d, on the v, and on the a, but I didn't bother putting an x or a y on the t? Times a scalar, which means I can use it in either one of these columns. And now you're starting to see why it's nice to know if you're working with a scalar. It means I can use it anywhere I want. Mr. Duick, what, Callie? I notice you put an initial there, but you didn't put an initial there, even though there is an initial there. True. You got a pretty good eye. How come I didn't bother putting an I here? Yeah, loud and proud. Look, if A is 0 then this V initial is also going to be the V final, is also going to be the V average, is also going to be the V middle, is also going to be the V after 1 second. You know what? I'm too lazy. It's that Vx can go there, initial final, doesn't matter. Here it matters because we have a changing velocity. Okay. What I want you to realize is that the vertical and horizontal components have no effect on each other. Let's do a little thought experiment. Let's suppose that I take my Airzuka and I carefully put it on my shoulder. I'm going to launch it like a bazooka, but I'm going to make sure I launch it exactly horizontally. I'll use a level and everything. And I have someone else pull the trigger. And at the same time as they pull the trigger with one hand, with their other hand, from the same height as my barrel, they drop a Nerf dart. So that one gets fired sideways, while at the same time one gets dropped down. Which one is going to hit the ground first? Carter, what? The same? How on earth can that be? Explain yourself, Carter, my friend.
It's
just a guess.
Well, it's either the same time, or the shot one hits first, or the dropped one hits first. So I guess I got a 1 in 3 chance. I'll take those odds.
When I fire this dart, what are the forces acting on it? Get the obvious one. Okay. What else?
It's a trick question.
Nothing. When I drop this dart, what are the forces acting on it? Get the obvious one. Okay. So, first of all, that means they're both accelerating at what? Negative 9.8 vertically. What's the initial vertical velocity of this dart when I drop it? Keyword dropped. What did we say if it was dropped? VI was? When I launch this horizontally, what's the initial vertical velocity, the split second it leaves the barrel? I know it's traveling horizontally, but how fast is it traveling vertically? For a trillionth of a second, right when it leaves the barrel. 0. Hasn't started falling yet. So, do they both have a VI vertical of 0? Do they both have the same acceleration? Are they both following the same vertical distance? Then Carter, amazingly, I think you're right. Put your pencils down, look up. This is another nice apparatus, but it costs about $500. Too cheap to buy it. So we're going to use a pole. We're going to level the pole very, very carefully, because for this to be bang on, everything's got to be nice and level so we don't introduce error. We're also going to put a little launcher. We're going to level that. And then here's, Peter, how this launcher is going to work. It's a spring-loaded launcher, so to arm it, we just pull the spring and we cock it. On the left-hand side, we're going to put a billiard ball that's had a hole drilled through it, and when we pull the trigger, this peg is just going to yank in, dropping the ball straight down, like this. On the right-hand side, we're going to put a ball on this platform right here, and this peg is going to knock the ball sideways, similar to the way my Nerf dart gun would launch something. So the right-hand ball is going to get launched horizontally. The left-hand ball is going to get dropped vertically. Which one's going to hit the ground first? Carter, what's your hypothesis? Carter says the same. Let's find out. Is he correct? 3, 2, 1. Yeah. Okay. In fact, years ago, in one of their final seasons, the Mythbusters looked at that. They rented an aircraft hangar, and they wanted to see if you fired a bullet and dropped a bullet, would they hit the ground at the same time. And it took a lot of finagling to try and figure out how you wire an electronic timer to both fire the gun and drop the bullet simultaneously, because it took longer than they expected for the gun to fire because it was a physical mechanism. But they were able to eventually tune it in so that boom, boom, and you saw the bullet hit the hanger ground right next to the dropped bullet. The fired bullet and the dropped bullet hit at the same time. If we were in Physics 12, I would say, I like example 1, I like example 1, example 1 is the next question. In fact, this is a test question on the first Physics 12 unit test. I give them a cliff, I launch horizontally, and I ask, find how far the projectile travels. So read along with me. It says this: a projectile is launched horizontally. I'm going to underline the phrase horizontally. From a 92 meter high cliff at a velocity of 19 meters per second. A says how long until the projectile hits the ground. B asks how far from the base of the cliff will a projectile hit the ground. There's a fancy word for this. This is called the range. When you're asking what the horizontal displacement will be, we call that the range. Who remembers, what does gulp stand for? This is well worth gulping. So I'm going to draw the cliff like that. David, what's the height of this cliff? So I'm going to go yoink, 92 meters, thunk. What else have they told me? What type of velocity? How is it launched? I'm looking for a word that starts with the letter H and is underlined. So I'm going to draw the velocity like this. D, and velocity is 19 meters per second. Have I drawn everything that the question gave me? I think so. This is a projectile T-table. Horizontal, vertical. What were the two physics no-brainers that I could write? Even though they're not really no-brainers. Now let's look at the picture. That 92, vertical or horizontal? Don't overcomplicate it. Yeah. I'm going to call that a D, but with a Y for vertical. Why is writing 92 wrong? Because it is. Okay, I've got to realize I'm going to end up below from where I started. If I'm starting here, my displacement is actually negative. Good. What about that 19? Vertical or horizontal? Look at the picture. I'll call that a Vx. Brandon, how many things do I know on the left-hand side? How many on the right-hand side? I don't even remember in that unit we always said I need 3 to find the fourth. So I guess that means I can't do this. Or can I? I know something else. I know this. The initial vertical velocity. What is the initial vertical velocity right when we leave the cliff for a split second? Ah! Okay. Brennan, what's part A asking me to find? Which column do I know 3 things in? Because okay. I'm going to solve for time vertically. I'm looking for an equation that has an A, a VI, a D, and a T in it. There is one. And your hint is we're probably in that second or third row down where the VF, VI, and etc. is. Which equation, Brendan, my friend? I'm going to write dy equals Vy initial T plus 1/2 AY T squared. By far the most common mistake is kids put a horizontal value into a vertical equation or a vertical value into a horizontal equation. You got to be meticulous. We could have been a bit lazy. How could we have saved ourselves some time? Yeah, I could have said yoink. And in fact, I really could have written d equals ay t squared over 2. Oh, and that's dy. There's my 1/2 at squared, although again I did the usual shtick of, oh, stop writing the 1 and just put the 2 on the bottom. How would I get the t by itself? Braden, my friend. Let's see, how to move the a over. What's the a doing to the t? Adding, subtracting, multiplying, and dividing. So how do I move the a over? Divide it. How will I move that 2 on the bottom over? That'll give me a t squared. Knock, knock. What will I do with the square root? Yeah, I think I'm going to get this, and you can walk through it, but I'm pretty sure I'm going to get 2 dy divided by ay square root. And do you mind? I'm going to put the t equals on that side because that's where they're used to seeing the thing by itself. Yeah, now might be a good time to reach for your calculators. It's going to be 2 times negative 92 divided by negative 9.8. Is that right? You can. 4.33. Is it even, or there's change? There's probably some more change after that. Okay, so store that on your calculator. If I knew I was going to lose it because I had to type some other stuff, I might write down 5 sig figs worth, maybe 6, depending on where a nice place is to round off. All right. Okay. Adam, what's B want me to find? Which D? Yes. It wants me to find that. So I guess I'm going to go over here and I'm going to go dx equals question mark. Uh-oh. Adam, how many things do I know in this column? I need 3 to find the 4th. Am I out of luck? Well, how can I somehow get something else here? It would be really nice, Ryan, if there was a scalar nearby that could go in either column that I had just found. Are you saying that I can put t equals 4.33 seconds? Better use my answer button instead? Yes! Now how many things do I know? Woohoo! I can find a 4th. Looking for an equation that's got an A, a B, a D, and a T in it. Don't let me spoil the surprise, but there is one. Wait, which equation? I don't know, VF. Nice try. Thank you for playing. Collect your consolation prize at the door. Try again. The same equation that we just... Really? So you're telling me it's going to be dx equals vxt plus 1/2 ax t squared. Although I think you allowed me to do some extra writing, wasting time. I can get rid of vxt?
Oh, no. You keep vxt, but you get rid of
The second part.
the half axt squared.
What witchery is the, what?
A equals 0.
Oh, I thought you were just magically doing it. Okay. Hey, I got this. So dx is going to be vx. Was it 19? T, I'm going to write 4.33, but you know I'm using my answer button. What do you get?
82.7.
82.3. If I go to 3 sig figs. Units, meters. So what we're saying, by the way, is where it hits right there, it's 82 point what? 3 meters. Okay. Moving a little furniture, are they? Basically, for any kind of a projectile question, two-dimensional motion, do a t-table, you know AX is 0, you know AY is negative 9.8. The rest you adapt. Sometimes VY initial won't be 0. That might be if you're launching it up at an angle. There might be both a vertical and a horizontal component to the velocity. Okay. Sometimes you'll be launching from a cliff. Sometimes you'll be launching from the ground. Okay. But this is our approach. We're going to pause. I'm not going to test you on this. That was dipping our toe into the waters. Let me hit stop.